going to start doing now in this chapter is we're going to learn how are the algebraic ways, the non-graphing ways that we can solve systems of equations. But in reality, we still want to have the same visual going on. When we find a solution, it's still an ordered pair. It still means those, if we get an ordered pair answer, that still means those lines are crossing. They have an intersection point. Those two lines have an intersection point. If we did graph them, they better intersect at that point. And there will be times that we will check it out and see with the graphing calculator. When we solve it algebraically, does the graph actually support our answer too? So here's what we're going to do today, we're going to be spending more than one day on this lesson. Today, we're going to focus in on finding the equation that is solved for either x or for y. So you're going to look at your two equations and you're going to say, is one of them solved for x? In other words, the x is by itself, or is one of them solved for y already? In other words, the y is by itself. And we're going to circle the expression it is equal to. So we're going to circle. Would you circle the word circle, even though it doesn't write anymore, it's more like oval? Circle. So we're going to say that x is equal to something. That's something. That expression it is equal to. We're going to circle that. Because that expression is going to be important to us. We're going to substitute that circle expression into the other equation. And this is really important that we understand now. We're going to take from what we got from the one equation, we're going to put it into the other equation, because they're working together, remember, they're pals. And we're going to solve that other equation first. Because what will happen is when we do this substitution step, we no longer have both x's and y's. We've gotten rid of one or the other. Either the x's will be gone or the y's will be gone, and we'll have just one variable to solve for, and we know how to solve an equation for one variable. Then we're going to substitute that solution. So if we solved for x, we're going to take our solution for x and we're going to put it into the equation that has the variable alone. If we solve for y, we'll put it in. So whichever one we have. Basically, if we've already solved for x, we're going to have to solve for y. If we've already solved for y, we're going to have to solve for x. We've got to have them both. And then we're going to put our solutions into an ordered pair, just like we did with graphing. These two lines would still cross on a graph. There still would be an ordered pair solution. We just are not going to get it from a graph. We're going to get it algebraically instead. Okay, so let's just do some practicing to make sense of those steps that we just outlined up there. Number one, here's our system. 2y plus x equals 4. X equals y plus 7. What's our first step? What are we going to look for?
If one of them is solved to either x or y.
Okay, do we have that? Which equation is solved already for x or for y? The second equation is, it says x equals, here's what x equals. X is already by itself, here's what it's equal to. What are we going to do with that thing that it's equal to? First we're going to circle it. So we're going to take this y plus 7 and we're going to circle it. We're going to say, this is the same as x. So what we're going to say is, well, now since I've identified that we have an equation solved for x by itself, here's our circled expression. Remember, we have to take the other equation. So now we're going to write down the other equation. So you really need to write down your system of equations first in your homework. Write down the two equations that you have to work with. Do what we're doing here. Say, okay, here's what I can circle. Now I need to write down the other equation because that's the one I'm going to substitute into. And where are we going to substitute into it? We need to sub in for that x, right? Because it says x is this. So we're going to sub the 2y is going to stay 2y. We're going to put in place of the x, and we're going to always do this in parentheses. We're going to sub in place of the x, our circled expression, and notice what happened. We no longer have x's. We just temporarily got rid of them. Or like, get out of the way for a bit here. We want to solve for y first in this case. So now we're going to simplify. The left side of this should look like something in your homework for today. We have an algebraic expression to simplify, don't we? What would that algebraic expression simplify? you know?
Um,
How important are those parentheses this time? Even though I said you had to use them,
very important.
are they really playing a role at all? They're really, in reality, we could have left them off because here's the deal. It's a plus, we're adding, and remember when we're adding, things go much better than they do when we're subtracting. And we're adding, there was nothing that x was being multiplied by. What's it actually being multiplied by? 1. And when you multiply by 1, does it change something? No, its value stays the same. So in reality, in fact, let's just do that. We can, it's like we're distributing a 1. It's like there's an invisible 1 there, and we're saying to get rid of the parentheses, we take 1 times y and we get y. We take 1 times 7 and we get 7. So we can just really ditch the parentheses this time. They weren't playing a very important role at all. Okay, now tell me what the left side, that algebraic expression, 2y plus y plus 7 simplifies to. 3y plus 7? What you said? That's what I thought. 3y, 2y plus a y is 3y, correct? And the 7 is not a like term, so it says, okay, I guess I just have to tag along. So it's 3y plus 7. The left side can simplify to that, can it not? That's why we were practicing simplifying. Now we're ready to solve. So would you put here right now, ready to solve. So today we're simplifying algebraic expressions within an equation. We're going to have to either simplify the left side or the right side before we can go about solving. So now we're ready to solve it. And now we got to draw upon our skills from last year. What do we do first? Subtract 7. We got to get rid of that 7 first. The tag along goes first. Get out of here, 7. The y's, even though there's more than one of them, they want to be by themselves. So it's 3y now by itself on that side, and 4 take away 7 is negative 3. I know, the alarm had to go off the other day. It stinks. Okay. What would we do now? Divide by 3. Yeah. So 3y is going to get divided by 3. Would you show it like that so you know that this was its own separate step? This is what we got after we subtracted. Now we're doing the dividing step. And after we do the dividing step, our y is by itself, and our y is what? What's negative 3 divided by 3? Negative 1. Circle that. That's kind of an important answer. It's part of our answer, isn't it? In fact, off to the side now, we could actually put that we now know part of our ordered pair solution answer. We don't know the x. We don't have that yet. We don't have the x yet, but we now know the y is going to be negative 1. We know that. That's what we just figured out. So what part of that do you need me to go back to and say, this is why we did what we did, or what's any concerns? Yes, Miguel.
I'm confused on the when you have the original 2y plus x equals 4. Do you always sub in the other equation there to figure out the y first?
Well, it depends on, okay? So the reason that we circled the y plus 7, so we're using part of that equation to help us solve the other equation. So we had to use this one, right? We had to use the other one. So that's why we wrote down the other one. Then we substituted into that one from, so we take our circled expression, and what we're really doing is we're replacing, because it says x is this, so we're going to replace the x.
So would they always be like that, or that we have to simplify?
Simplifying for, oh, no, you probably won't have to simplify first, but you got to make a decision which one is going to be used in the other one. Okay, does that make sense? Okay. Anybody else? Okay, so now what did that step say now? After we substitute and we get this first solution, what are we supposed to do now? I think it's step number B. What does it say to do? Substitute that solution into
Equation variable.
into the equation with the variable on it. You know what, it really would not matter which equation you use. You could take the first equation or the second equation, substitute the y value into it, and solve the equation for x. But I'm trying to save you a little bit of work. If we need x, we already have an equation that says x is, and remember x is, what was it again? What's the circled expression? Y plus 7. So we'll use that equation because it's going to make a whole lot less work for us. X equals, we now know that y is -1. So we substitute -1 in for our y. And we say, oh, well, x is what? What's -1 plus 7? It's 6. So we now have our x value. On a graph, these two lines would cross where? At ordered pair, 6, -1. So if we had solved this by graphing, we would have, first of all, we would have both of them in slope-intercept form, in graphing, friendly, ready. And then we would have graphed them both, and then we would have gotten the same exact solution. Okay? But we're doing it algebraically and saying, oh, okay, what if I go on a graph? What if Mrs. Lebrun's not providing me with a nice coordinate plane for me? Can I use a different method? I'm teaching you the substitution method. Anything we should talk about further with this problem before we try another one? Okay, let's go to the back then. You go ahead and circle what you think should be circled. What do you think should be circled? Okay, offer up for me. What should be circled in this one? Calvin, what'd you circle? Okay, what did you do it? Abby? X minus 2. Yeah, Abby, why did you circle the x minus 2? Because it says that's what y is, doesn't it? It says y is. Remember, we want the equation that says either x is or y is. That's what we want. We want the equation that states it that way. And we say, oh, well, if y is this, why don't I use this in the other equation? So now we're going to write down our other equation, 2x. What are we going to do with that subtraction, do you suppose? Change it to add the opposite. So 2x plus what? -4y equals 4. Okay. Now we're going to substitute. This gets a little trickier because now it isn't just y by itself, but a -4 in front of that y, isn't it? So we're going to substitute. So what I want you to do is I want you to take in this equation, we're going to substitute for that y because that's what it says. Y is that. So circle that y and say, this is what's going to get replaced. This is what's going to get replaced. And I'm going to replace it with what was circled up there. So we have 2x plus -4. And when we substitute, remember we're putting it in parentheses. Whatever is getting substitute goes in parentheses. And bring down the rest of the equation. So the only thing that looks different right now is the y is now x minus 2. See that? Before we move on though, what do you suppose we're going to do with that x minus 2? It's subtraction, so we're going to add the opposite. We're going to change that also. So this is going to become x plus a -2. So on the right side, we have that 4 all by itself. Does it need any simplifying? Does the right side need any simplifying? No. Does the left side? Absolutely. This should look like what you just did for today, doesn't it? This looks like a problem on our Ray Flug worksheet. 2x plus negative 4 times x plus negative 2. That needs to get simplified. So can we do anything with the 2x right now? No, we're going to bring it down. And what are we going to do? We're going to do this distributive property, don't we? So what does negative 4 times that expression, x plus negative 2, become? What is it? Negative x?
Positive 8.
Negative 4x, first of all, plus what? Negative 4 times negative 2 is?
Plus positive 8.
Positive 8, and then we bring down our equals 4. So we've started simplifying it. I'm going to guess that in your homework for today, it wasn't just a one step all the time, was it? You had to do 2, sometimes 3 steps to get it simplified. Okay. What can we put together?
With negative 4x and 2x.
Yeah, those x's can be put together. What do they become?
Negative 2x.
Negative 2x. Combine these guys, this part right here, the 2x plus the negative 4x becomes negative 2x. 2 plus negative 4 is negative 2. X's added to x's stay x's. Bring down the plus 8 equals 4. More simplifying to do, or now are we ready to solve? Are we ready to solve, or we still need to simplify? Can we simplify anymore? Can the negative 2x be put together with the 8? No. So we're ready to solve. Ready to solve. It's a good idea to understand, when are you simplifying, when are you solving? When you're simplifying, you're just doing the stuff right there on that side. Once you start solving, you're now working on both sides of the equation. So what should we do first here? Subtract 8. Okay, so we'll subtract 8. Bring down our negative 2x, that's now by itself. 4 take away 8. Negative 4. Next step. Divide both sides by negative 2, so negative 2x gets divided by negative 2, negative 4 gets divided by negative 2. And we have our solution for x, which is positive 2 or negative 2? Positive 2. So this time we just have to solve for x first. We now know that our ordered pair is going to be 2, comma, we don't know our y yet. Okay. Questions on any part of that? Suggestion how we can make our life pretty easy to get y. Which equation do we use? Do you want to use 2x minus 4y equals 4 and substitute your 2 in for x and then get that solve for y? Or do you want to use the y equals x minus 2, substitute in for x and do one little tiny step, right? So I'm thinking that would be the route to go. Let's take the y equals, and what was it again, x minus 2? Did I do that right? No, y plus 7. No, oh gosh.
It's x minus
Oh, I must have changed. Oh, we're on the back side. That's the problem here. Okay, so it's x minus 2. Okay, so I got that. So we're using that equation. We're going to substitute into it to get our y value, aren't we? So y equals, we say x is 2. Y equals 0. Uh-oh, did we do something wrong? We got 0. Is 0 legit? Yeah. Our solution is ordered pair 2, 0. This is where those two lines would cross on the graph. Cross on the x-axis at 2, 0. Okay, you get yourself started on 3. Cool. Show me you know what you're doing. After you've done your circling and substitution step, look up and make sure that you're taking a good process, a good road to help you be successful. Notice what I did with my negative y. What did I do? I made it a plus a negative y, and then I said that negative sign is the same as a what? Negative 1. There's an invisible 1 between that negative sign and that y. Really important that we put that negative 1 there. So the negative 3x plus 5 is the expression that you should have a big circled expression basically. That's going to now get substituted into the other equation. So the reason I circled the y was to say, okay, here's where I'm going to sub into the other equation. Before I did, I changed the subtraction in the second equation to add the opposite. Now I said, oh, I better treat that negative sign as a negative 1. And now I'm ready to start simplifying. You agree? Okay, now simplify. Let's see if we end up with the same thing there. Simplify the left side of this equation. Make sure you have a good simplified equation before you start to solve. Once you can't simplify anymore, then you are going to say, I am ready to solve, and if you need to challenge me because you say, I don't think you did that right, Mrs. LeGrand, let me know. You're going to be solving the same equation. Any challenges out there? Do we agree on the equation that we have to solve here? We're going to be solving for what? This time we're getting what first? The x's first. Okay, so what do we do to solve this? What's our first move? Add 5. Add 5 on both sides. Remember, once we're solving, we're doing it on both sides. We're done simplifying. We have our 5x alone now, and that? Yeah, okay. I really don't want to work very hard, so I say, oh, I like the equation that y is by itself, since that's what I need is y. And I substitute into that what I got for x to figure out my y. I did my before. You agree? Okay, what's our final answer then? Ordered pair 3, -4. This is where we could count on that the graph lines would intersect at that ordered pair. Notice we're not doing check problems today. This is enough right here just to solve them. We're gonna see how we do when we actually break down one tomorrow, okay? Any questions left out there lingering that you need to have answered yet? We're gonna start practicing. You should be able to do your work right on the worksheet, I think.